SSRF with blacklist based input filters. So some applications block input containing sensitive URLs like /admin. If this happens to you, try these tactics to bypass the filter. Let's understand this with a practical example as shown on the screen. Original URL which is shown on the screen is blocked. To bypass the filter that blocks /admin, the attacker URL encodes the letter A as %61. So instead of using the string /admin, the attacker uses /61 DMIN in the URL. The resultant manipulated URL as shown on the screen is the one which bypasses the filter. Now SSRF with white-based input filters. Some applications only accept inputs that match an approved list of values, with filters looking for matches at either the beginning or within your input text. You can get around this filter by taking advantage of any inconsistencies in the URL parsing that could occur. The URL specification contains features that may be overlooked when parsing and validating URLs using this method. We can see some of these examples as shown on the screens. Credentials using @character. We can use the following URL. As you can see in the URL format, the username is set as vulnerable.com and a fake password, example fake password in this case, is used before the hostname /admin panel. The SSRF filter may not account for embedded credentials and could allow the request to pass through. Second one being URL encoding characters. We can use the following URL. The minus character in the hostname /admin/ panel is URL encoded as %2d. Some SSRF filters may not handle URL encoded characters correctly, allowing the request to pass through the admin panel. Third one being double encoding the characters. So the -- character in the host name /admin panel is double URL encoded as %25do. Some SSRF filters may decode the characters only once, allowing the request to pass through even when it's interpreted as a single URL encoded character. Next one being bypassing SSRF filters via open redirection. So sometimes it's possible to bypass filter-based defenses through exploiting open redirection vulnerabilities. Imagine that in our previous example, users submitted URLs are strictly validated to avoid exploiting SSRF behavior maliciously, yet their allowing application contains an open redirection vulnerability that allows for redirections. Assuming the API used to make HTTP requests supports redirection, then creating a URL which fits through the filter and leads directly to the desired destination, resulting in redirecting requests towards desired backend target. You can understand this with the help of a following example as shown on the screen. So here you can see that there's an original URL with open redirection vulnerability, and SSRF URL is as follows. Finally, let's see some of the ways which can help us in fixing these vulnerabilities found in SSRF. Whitelist and DNS resolution. A solid approach to avoiding SSRF is to whitelist the IP addresses or DNS names that your application requires access to. Only if a whitelist approach is not suitable, you should use the blacklist. You must also authorize user input effectively. For instance, do not permit requests to private IP addresses. In the instance of a blacklist, the appropriate mitigation strategy will differ according to the application. Thus, there is no one-size-fits-all fix to SSRF, as it is very dependent on organizational demands and application functionality. Second one being response handling. To stop response information from reaching the cyber criminal, you should make sure that the response that is received conforms to what is anticipated. Under no circumstances should the raw response body from an order initiated by a server be shared with the clients. By disabling unused URL schemas, if your application is solely reliant on HTTPS or HTTP to initiate requests, permit only these URL schemas. You deny attackers the ability to utilize the application to carry out requests via potentially harmful schemas, including dict//file// and gopher//. Fourth one being authentication on internal services. Redis, MongoDB, Elasticsearch, and Memcache services do not automatically require verification by default. As this could allow cybercriminals access to SSRF vulnerabilities without verification for your application security, it is preferable to allow verification whenever possible, including local network services. Secure third-party services and libraries. Ensure that third-party services and libraries used in your web applications are up to date and configured securely. Sixth one being monitor and log requests. Implement monitoring and logging mechanisms to detect and investigate potential SSRF attacks in real time.